Hi, let's get started. Create a folder RPS game. Open that folder in Visual Studio. We are going to create a new project inside this folder. Create New Project. It displays list of templates. Search for ASP, NetCore Web API Project Template. Type project name as RPS Game. By default, the solution name will be same. If you wish, you can change the solution name. Then click on Next. Check Use Controller if unchecked. Click Create. Now this creates the project template. Wait for a few seconds. The project has been created with controllers in it. Now, create the necessary files. Right-click on the project name and add file move.cs and click on Add. Similarly, again right-click on the project name, create game request, CS file and game result, CS file. All these three files are public and holds the required get-set properties for developing the application, especially for building the game logic. Now, right-click on the controllers folder and add new controller. Search for API controller. API controller enforces API-specific conventions and behaviors. Rename value controller as game controller. Let's start coding. Open move, CS file. Here, using a C# enum, define the possible moves in rock, paper, scissors. We define an enum to clearly represent the possible player moves. It is easier to maintain. Open game requests, CS file. This game request class holds the player's move. It contains a single property. The object will be sent from the Angular frontend to the API when the player selects rock, paper, or scissors. Now open game result, CS file. The game result class holds the outcome of the match. It contains three public properties, including the player's move, the computer's move, and a result message that shows who won. The player move represents what move the player chose. The computer move represents what move the computer chose. For example, rock, paper, or scissors. The result represents the outcome of the game in the string format. For example, you win, you lose, or it's a tie. Mention question mark after string. Tell C# that this property is nullable. It can hold a valid move or null. Then click on File to save all. Open Game Controller to write game logic. Here, HTTP post attribute named play defines an HTTP post endpoint at API game route. Declare play method with return result type as iActionResult. The play method responds to a post request at API/game route. It receives the player's move from the request body using from body game request. Now, using random class, create a new random number generator to simulate the computer's move. Create an object, computer move, to randomly pick the computer's move, rock, paper, or scissors. Declare a variable, result, to store the result of the game. Now, write if-else condition. Check if the player's move is the same as the computer's move. If so, then the result of the game is draw. Then write else if condition. This line of code is the core logic that checks whether the player has won in a rock, paper, or scissors game. Check if the player's move beats the computer's move. Check all winning conditions. Rock beats scissors, paper beats rock, or scissors beats paper. If any condition is true, set the result to you win. Check all winning conditions. Rock beats scissors, paper beats rock, or scissors beats paper. If any condition is true, set the result to you win. Else, set the result of the game as you lose. Now, return an OK response containing a game result object. This OK response includes the player's move, the computer's move, and the final result, all sent back to the front end to display the outcome. Save the code, as we written the perfect logic of the rock, paper, or scissors game. Let's run and test the code using Swagger. Okay. Now, in the request body, the player's move is sent as an integer. That is 0 for rock, 1 for paper, and 2 for scissor. When we run the game, the backend generates a random number between 0 and 2 for the computer's move. Based on the logic we wrote, it compares both moves and returns a result. Now, open program.cs file. Just read out the comment I'm typing, and guess what we are going to do next? We are going to use some advanced option of .NET to our gaming application to make it more readable. For example, you see rock in a string format instead of 0. We are going to configure ASP.NET Core to use JSON string enum converter. This improves readability, front-end integration, and debugging clarity. Let's see how to implement that. We're going to configure ASP.NET Core to use the JSON string enum converter by adding JSON options to the controller configuration. This will let us work with enum values as readable strings like rock instead of integers like 0. This code tells ASP.NET Core to serialize and deserialize enums as strings instead of integers in JSON. It's done. Save all, and let's test the code. Let's wait. Code is running. Swagger gets loaded. Let us start testing the code. Yeah, now we can see it's showing move in the string format instead of number. Yeah. Our logic shows perfect results based on the match conditions like you win, you lose, or draw. It's comparing both the moves of computer and player. Here, let's see what's the result of the game. We won. Okay. Now, we have successfully completed the backend logic. Let's start building the UI using Angular. Open Visual Studio Code. Open the existing folder path, and inside that folder, create a new folder. Name it as RPS, Frontend. Open that folder in Visual Studio Code. Now to open Terminal, click on Terminal, then click on New Terminal. It's loading. Wait for a second. Here, we're going to create an Angular app. To create an Angular app, type ng new rps-game. In this application, no need of routing. So, we're going to set the routing to false. Then, set the style to CSS. Then click Enter. It loads and asks for the wanting of server-side rendering and static site generation. We're going to set No. And then click Enter. The node modules and packages gets installed. Wait for a few seconds. Now, navigate to the project. It's initialized with Git. Run the created Angular app using the following command. It will show whether we are willing to share our code to Angular team under Google privacy policy. We are going to set No. It loads and generates an URL. Check it by pasting it on Chrome. Yeah, app is working fine. Now we need to create game component. Open another terminal. Type ng, give space, type generate, give space type component, another space, and then type game, and then click Enter. The game component is generated with 4 files in it. And then install Bootstrap using the following npm command. Wait for a few seconds. It's done. Now search for styles, CSS file. Import Bootstrap inside it. Actually here, we can add global styles to this file and also import other style files. Actually here, we can add global styles to this file and also import other style files that is required for the application. Remove Git if it's initialized using following command. Yeah, Git is removed now. Open app.component HTML file. Remove the existing code from it. Now, import game component inside app component using HTML tag. And then, import the game component inside app component, a TS file. It will load the game component in the root component. Actually, we are working in version 18, so our application is a standalone application. In TS file of game component, import HTTP client, which is used to make HTTP requests to your backend API. Then, to map player move to backend enum, we define a move type for valid strings, rock, paper, or scissors. This defines a custom type move that can only be one of the 3 strings, rock, paper, or scissors. It ensures type safety when passing or using move values. Then we use record of move and number to map the frontend string values to match the backend enum values. This creates a typed object where each move key maps to a number. For example, 0 equals rock, 1 equals paper, and so on. Hope you understand TypeScript's type and record utility to define a strongly typed mapping between string-based moves and their numeric enum values. Let's learn How to communicate with backend now. First, declare a variable, result, that holds the response from the API after the game is played. We can bind this in HTML to display the result to the user. Then, declare constructor to inject Angular's HTTP client so we can make HTTP requests to .NET Core backend. Then, write a method to trigger when the player selects a move that is rock, paper, or scissors. It accepts a parameter of type move, which is a type alias ensuring that only valid values can be passed. Then, it maps the move to a numeric value with const variable and sends it to the API. Here, moveIndex converts the string rock into its corresponding enum value 0 using the move map. Now, we are going to send a post request to our .NET API with the player's move. Notice from where we are getting the link to pass. It's the request URL from post method in Swagger. For that, run the backend code. Paste the link and pass a JSON object in the body with the player's move converted to a number. For example, 0 for rock, 1 for paper, and so on. Now add subscribe method, which is used to handle all the asynchronous response from the API. Declare next inside subscribe method, which runs when the API call is successful. Once the response is received, we store it in a variable named result to display the game result. We log it for debugging. Then declare error, which runs if something goes wrong and logs the error in the browser console. Okay, it's done. Let's start coding user interface. Open game.component HTML file. Just remove the existing code. We're going to build a Bootstrap-styled UI with 3 buttons for rock, paper, and scissors. On click, Angular sends the selected move to the backend and displays the result dynamically using ngIf. So, we're adding the heading tag h1 as follows: rock, paper, scissors. Heading tags h1, h2, and so on gives different font sizes. Add second heading tag h2 as follows. Let's play. Add another division tag with the class button group to add 3 buttons to click the moves rock, paper, or scissors. We're going to assign a role and label too. For themes, we can use primary, secondary, and danger of Bootstrap themes. Add a click event to bind the play method of TS file of game component. The way we pass moves with play method to user click event is called event binding, where the data flows from component to class, that is, TS file. Write another div tag to display results. Use para and strong tags to display texts. Displays result only after receiving a response from the API. So use ngIf to conditionally render the component. The double curly braces is an Angular's interpolation syntax, which is used to display dynamic data from your component in the template. Result is the variable in your component that holds the API response. Player move is a property from that responsive type string, like rock, paper, or scissors. Result player move renders the player's move in the HTML once the API returns data. All the classes we mentioned here, like container, text center, MT5, button group, extra, are Bootstrap classes for layout and styling. In the terminal, it throws an error for ngIf statement. Let's solve it. I think we missed a module package to import it in TS file of game component. Import common module so Angular features like ngIf and ng for work properly in our component. Import HTTP client and HTTP client module as well to send requests to our .NET Core API. Now we're done with the Angular development. Let's check the output of the application. UI looks fine, but button isn't working. So, inspect it. Go to console. Oops. We missed to add CORS policy to the backend. Stop the running application in Visual Studio. Open Program, CS file. We're gonna add CORS policy to our backend application. CORS represents cross-origin resource sharing, which is a security feature built into web browsers that controls which domains are allowed to access resources on your server. We are configuring a cross-origin resource sharing policy using options method, a perfect for local development between Angular and .NET Core. In our application, we are configuring it by naming as allow all to enable cross-origin requests from any domain, method, or header. Don't forget to also apply this policy in the HTTP request pipeline apt.useCores, allow all. Place this before app, use authorization method in program, CS file. Save the code. Open Launch Settings, JSON file. Remove the secure connection of HTTPS to HTTP. Now, run the application. We are done with the corrections. Wait for a second. Application is running. Swagger gets loaded. Now, execute the play. Check for request URL. It will be represented as HTTP instead of HTTPS. So, change it in the front end too. Now, check the URL with port number 4200. Let's play the game. Let us choose rock. Computer chose paper. We lose.
Haha.
It's draw. I think I like to click the buttons and I'll try until I win. It's very interesting, right? Hope you find it very interesting. Okay guys.
Bye.
Thanks for watching. See you in the next video. If you like this video, please do like, share, and subscribe our channel.